Hello, this is Jeremy again, and in this video we're going to talk about how to do a hypothesis test for proportions using the calculator. Now, I'm assuming you've already looked at videos for how to handle the mean, and I think you should look at those before watching this video because they explain some of the background details, but essentially the same procedure we use there we're able to use here. Now, I don't know if I have to tell you this. This is an extremely made up example. I don't know what kind of researcher would research something like this. But it's, for the sake of argument, we'll say, okay, somebody really has this question and they really have this data. Okay, so with that said, let's take a look at what this problem's looking for. So we have a researcher that believes more than 65% of people can name 3 characters from The Simpsons. So he gets a sample. If you have a idea like this, the way that you prove it is you get a sample and you get a small p-value. And so you can actually do this with anything. And so, okay, you got a sample of 200 people and 120 could name 3 characters from The Simpsons. Is this enough evidence to support his claim or his belief? Okay, so just like we did with means, we're going to write down our H0 and HA first. So some textbooks use pi. I'm going to use p. And so what we're wondering is, does it support the claim? And the claim was more than 0.65. P is more than 0.65. So the complement to that would be p is less than or equal to 0.65. Okay, the less than or equal has the equality, so it's H0. And the HA is whatever's left over. Okay. Now the next step is to either draw a rejection region and calculate a test statistic or use the p-value method. And like I said, I'm going to use the calculator, so I'm using the p-value method. So we're going to use our calculator to get that p-value. And so on the calculator, what we're going to use is called a 1 prop z test. And so 1 prop z test is allowed as long as you have a large sample size, which we do, because this will follow an approximately normal distribution. Okay, so on your calculator, the first thing that you're asked for is p0. P0 with a little 0 on it comes from your H0 and HA, and that's the 0.65. Then you're asked for x. X is the number of successes, and that's whatever you're counting. So in this case, that's 120. And then n is your sample size, that's 200. The next line is asking for what tail test it is. This is a greater than on HA, so it's a right-tailed test. And then all you got to do is calculate. And so now I get a lot of information out of the calculator. The z equals negative 1.48. That is the test statistic. So if you hand calculate the test statistic, you should get the same thing. We don't need that if we're doing the p-value method. We just need the p-value, which in this case is 0.9309. This is a very big p-value. This is certainly bigger than alpha. So anytime you get a big p-value, it means that you don't have a lot of evidence for HA. It's not a very convincing evidence at all. And the bigger the p-value, the more you're kind of saying, well, there's not much to look at here. So this is a very big p-value because they can't be bigger than 1. So if p is bigger than alpha, I fail to reject H0. And so my final answer to this would be that no, to actually answer the question, the evidence does not support the researcher's claim. So again, we're saying with the p-value being this big, that there's a very, very high chance of getting a sample like this if the null hypothesis is true. So it's very little reason for us to look at HA. It's only when the p-value is small that we say, hey, something interesting is going on. It's very unlikely we got a sample like that, but we did. And that's what makes us start questioning H0. But in this case, a big p-value, we don't end up questioning H0.